Alright, so in this section now, 6-8, we're going to be looking at the graphs of the rest of the trigonometric functions. Remember, up to this point, we've only really looked at the graphs of sine and cosine. And so here in this section, we're going to look at the graphs of the 4 other trigonometric functions. Okay, starting with tangent and cotangent. And so right away, the first major difference that you should notice is the shape of the graph. So instead of kind of an oscillating curve between 1 and -1, like sine and cosine are, tangent and cotangent, number one, they're not continuous. Okay, it's kind of a curve, and then it has a break, and then it repeats. All right, and then of course cotangent just kind of shape the opposite way there. Now, the other major difference that we should notice right away is the period is not 2 pi. Okay, so the period for tangent and cotangent is going to be pi, because after pi is when it starts repeating its cycle again. So those are the 2 major differences that we should notice right away, is the shape of the graph and the period of the graph. And then, of course, we have some of the other characteristics that are here. The domain is all real numbers, okay, for tangent, except multiples of pi plus pi over 2, because that's where the vertical asymptotes occur, right? And of course, so there's no those values would be out of the domain. And let's see, on cotangent, it's the same idea except without the plus 2 pi, all right? Because of the fact that the asymptotes will shift when you go to cotangent. All right. Let me see here. What else we've got? Range, all real numbers there for both of them. Let me see here. X-intercept are expressed as multiples of pi, comma 0, because that's where we cross the x-axis. X-intercepts on cotangent, you just got to add a pi over 2 to that. Let's see here. Y-intercept for tangent is at 0, 0, and non-existent for cotangent. And as far as symmetries are concerned, they're both odd functions because they've got origin symmetry. All right, and so down here we've kind of got the general form and how to find the period and the phase shift. All right, and so again, the adjustment for period mainly is the only one that's changes. Instead of 2 pi over b, like it was for sine and cosine, it's just going to be pi over b. All right, so that's just kind of the main thing to make sure that we consider. All right, so again, all the characteristics for the graph of tangent and cotangent are here. So let's take a look at secant and cosecant. And now, first of all, with cosecant, okay, it is shadowed by the sine function graph, because it kind of follows the sine function as far as where these maximum and minimums are on the sine function. That's where the vertex of this particular, or I should say the minimums of the, or maximum, depending on which way it's turned, of the cosecant function would intersect with the graph of sine. And then likewise with cosecant, it kind of follows or shadows the cosine function. But of course we can notice right away the difference in the graph. So it's almost like I would almost say a parabolic type shape, opening upward on the maximums of the sine function and opening downward on the minimums. All right. And let's see, just some of the main things to look at. Period, we're back to 2 pi because you've got one opening up, one opening down before it repeats, and it's a full 2 pi, so we're back to 2 pi for the period on both of these. As far as the range is concerned, though, notice it's just everything that's less than or equal to -1, or greater than or equal to 1 on both of them. It's the same. Period is the same for both of them. This one doesn't have any intercepts right here as far as the y-intercepts or x-intercepts for that matter. And then right here when we go to secant, it does have the one y-intercept at 0, 1. Vertical asymptotes also still exist here. So for the cosecant, it's at multiples of pi is where your vertical asymptotes are. And then when you shift it over to secant, then you just have to add a pi over 2 to those intervals, and then you'll have it. Okay, it's an odd function for cosecant because of the fact that you still have origin symmetry as you move through. And actually when you move it now to cosecant, it's an even function because it's got y-axis symmetry with the way that it shifts. Okay, and again, you've got your equation here with your period, which is back to 2 pi over b. Right? Can't really see that, can you? Is back to 2 pi over b, and then your phase shift is still c over b. So those are going to be the same. All right. And so again, you've got a little chart with all the characteristics of each one of those functions there that we can look at. All right. Now, the next thing that we want to kind of just briefly get into is what is known as damped trigonometric graphs. And so that's formed by taking one of the trigonometric functions here, and we're just going to be looking at sine and cosine for this, is going to be taking it and multiplying it by another function. So the case that we're going to look at is if we multiply the sine function times x and kind of see what happens here. All right, so what we can kind of look at here is, think about this. Remember the shape of the sine function, all right, kind of that curve, oscillating curve between 1 and -1, right? So if we were to multiply that times another function, let's say, so instead what technically happens here is, instead of that sine curve being bounded or oscillating between 1 and -1 like it typically would, if you multiply it times another function, in this case x, then the curve is bounded by the product with that other function instead of being bounded by 1 and -1. All right, and so here's what we mean by that. So if we just kind of take a look at what the product of these two functions would be, right? When you take a look at the value, then you know that the product of those two has got to be between -x and x, right? And so really, what we're looking at as far as a graph of this thing is concerned, instead of being bounded, like we said, between 1 and -1 like it typically is, the curve is now bounded by y equals x and then y equals -x as far as the maxes and minimums are concerned with how high the function reaches, right? And it's because that curve is being multiplied now by an x function, all right? And we're not really going to do much with these, just aside from taking a look at what the graphs look like. So there's not going to be really much of anything that we get into that's real in depth with looking at these. I mean, like I say, we're not going to really do much of anything with these beyond saying, hey, look, here's what the graph looks like, and here's how it changes when you multiply it times x. Is basically all we're going to do with this. And then it goes on to kind of show you where the graph touches those lines of y equals x and y equals -x, and goes on to describe where the x-intercepts would be. All right. And of course, if you wanted to take a look at, let's see, if you want to take a look at what cosine would look like, okay, it's kind of the same idea. So if I come here and I go x times cosine of x. All right, so we can see it's still damped or bounded by those same two lines, y equals x and y equals -x, but just reflects what the cosine curve would look like as far as the shift, instead of what the sine curve would look like. Does that make sense? All right, so like I say, we're not going to really do much with these damped graphs, aside from just saying, hey, here's what they look like, isn't that cool? So that's kind of all we do with that. All right. And so now the type of problems that we're going to be looking at are going to be, we're given some equations with some of the 4 new trigonometric functions that we've studied in this section, and we're asking for the period, the phase shift, and the vertical shift. And so with this one, the first thing that we can go through is take a look and see if we can find the period. And so remember, with the period, and we're looking at tangent here, The main thing to remember is the period is pi and not 2 pi. And so when you're going to find the period, it's pi divided by b, right? Not 2 pi divided by b. And remember, you can get your b value from the coefficient of this x. And so the thing to remember here is it's not 2 pi divided by my 2. It's just going to be pi divided by 2. And that is as simple as it gets. And so that's your period, right? Let me see here. What else we got? Let's see. The next thing that we're looking for is the phase shift. Alright, and remember, for phase shift, we want C over B, so that doesn't change. And remember, your C is here, your B is here. Alright, so let's go through and look at that. So my value of C right here is going to be 11 pi over 6. So we'll go 11 pi over 6 divided by the b, which is 2. We'll go ahead and make that 2 over 1. And so we'll multiply by the reciprocal. 11 pi over 6 times, flip the denominator there, 1 over 2. And so that would be equal to 11 pi over 12. And so remember, we kind of ignore the sign until the very end, then we go back and look and say, okay, which direction? Minus, and so that would shift it 11 pi over 12 to the right is the answer there. Alright. And then, of course, the vertical shift is the last thing that it asks for there. And, of course, the vertical shift is going to be 1 down. Alright, let's try the next one. This one is cosecant. Okay, so we need the period first. And of course, with cosecant, then don't forget that your period is back to 2 pi. And so the period is going to be 2 pi over b. So we've got 2 pi over. And so what's my b here is 1/2. So that's divided by 1/2. And so that would be 2 over 1 times 1/2. Flip that to 2 over 1. And that will now become 4 pi. And so that would be your period for this one. We need the phase shift. And my phase shift now, remember, is still going to be C over B. Right? And so my C here in this case is going to be 3 pi over 4. 3 pi, make that over 4. I know it's a fraction divided by a fraction, so I'll go ahead and write them like this. And my B here is 1/2. And so let's see what that becomes. 3 pi over 4 times 2 over 1. So we've got 3 pi over 2. So now we can go back and take a look at the direction. 3 pi over 2. Plus there, we shift it to the left. Okay? And the only other thing we need to look at is the vertical shift. And in this case, there is none. Alright, so there you go.